All right, let's go over some optional 4.0 practice answer key. In this first question, you're going to be writing the chemical formulas for everything that is listed here, everything that is named here. We got a mixture here of ionic, covalent, and then ionic with transition metals and polyatomic ions. We're doing it all right here. Well, let's go ahead and get started. Magnesium sulfide. This is a metal and a non-metal. And I know the symbol for magnesium on the P table is Mg. And sulfide tells me that this is sulfur. And now I need the charges of both of those elements. So I'm going to use this periodic table with charges. Magnesium is 2 plus, and sulfur is 2 minus. So I write those up here. And now what I've got to do is swap and drop those charges. So the 2 comes down there, and that 2 comes down there. Remember, it's only the numbers, not the plus and minus. And so we get a 2 and a 2. But that is a ratio that can be reduced. 2 over 2 is the same thing as 1 over 1. So we have to reduce it to the smallest whole number ratio. So we get Mg1S1. Let's do barium fluoride. Barium is Ba. Excuse me. Fluorine is F. And we look up our charges. This is an ionic compound again. Barium is right here, 2 plus, and fluorine is over here, 1 minus. And so we add those charges, 2 plus and 1 minus. And now we swap and drop those charges, where the 1 goes down to barium and the 2 goes down to fluorine, and we cannot reduce that anymore. So BaF2 is our formula. Dinitrogen monoxide is letter C. I see prefixes, so this means this is a covalent compound. I don't have to do any swapping and dropping. Dinitrogen means N2. Monoxide means 1 oxygen. Done. Iron 3 oxide, that's a metal and a non-metal. This is an ionic compound. Iron symbol is Fe, oxide is O. This Roman numeral right here tells me that iron has a specific charge of 3 plus, like this one. Not 2 plus, but 3 plus. That's why the Roman numeral is there. Oxygen has a charge of 2 minus. And now I swap and drop those values. The 3 goes down here, the 2 swaps on there. And we can write our formula without the charges, Fe2O3. Iron 2 oxide is a little different, right? This time instead of Fe3 plus, we've got Fe2 plus and oxygen 2 minus. When we swap and drop those, we get 2 and 2. Just like this example up here, that can be reduced. So our formula is FeO. 2 and 2 reduces to 1 and 1. Potassium nitride. No prefixes, so I know it's ionic. Potassium is K, and nitride is nitrogen, N. And I look up their charges. Potassium is right here with 1 plus. Nitrogen is over here with 3 minus. And now I swap and drop those charges. The 1 comes down there on nitrogen, and the 3 swaps and goes on potassium, but at the bottom. And now I get K3N. Remember, we're not going to write that 1. So that's just K3N. Oxygen dibromide, I see a prefix. I know this is covalent, so I don't need to swap and drop. I just need to write it. Oxygen, no prefix, means 1. Dibromide, Br, di means 2. Diphosphorus pentoxide, again, prefixes, so I know it's covalent. So phosphorus is P, di means 2. Pentoxide is O, and pent means 5. P2O5. Let's jump over here to this other column. Copper 2 chloride. Copper is Cu, right? There's no prefixes, so I know this is ionic, so I've got to swap and drop. That tells me the charge on copper. It's 2 plus. Chloride is Cl. I look at my P table right here, and chlorine is -1, or 1 negative. Swap and drop. The 1 goes down there, the 2 goes down there. We get CuCl2. Phosphorus pentabromide. I see prefixes. Phosphorus is P. No prefix means 1. Pentabromide. That's Br for bromine. Penta means 5. Dinitrogen trisulfide. Prefixes again. I don't need to swap and drop. Dinitrogen means N2. Trisulfide means sulfur. Tri means 3. So S3. Calcium nitrate. No prefixes, so it's ionic. I've got to swap and drop. Ca for calcium. We look it up, it's right there, 2 plus. Nitrate. Now that one's different, it ends in ATE. So if we look up here, we've got the formula for the polyatomic ion. We're going to put that in parentheses, NO3, and we have a -1 charge. Now we swap and drop. The 1 comes down there. The 2 goes outside the parentheses. We get Ca, we're not going to write the 1, parentheses NO3, parentheses 2. Aluminum sulfate, no prefixes, got to swap and drop. Al is for aluminum, the charge is 3 plus. Sulfate, we see that ATE again. That means it's a polyatomic ion, it's right there. Or it's on this paper, sulfate, it's a little harder to find there. So parentheses SO4 with a 2 negative charge. So we swap and drop. This 2 goes down there on aluminum, that 3 goes outside the parentheses, we get Al2, SO4, 3. Nickel 2 phosphate. Now we're going to combine here transition metal and ATE. That means, and we're doing polyatomic ion. So nickel is Ni, 2 means 2 plus. Phosphate is right there, PO4, 3 negative, in parentheses. Swap and drop, the 3 comes down on nickel, the 2 goes outside the parentheses. We get Ni3, PO4, 2. Right, 2 more to go. 10, 4 hydroxide. The symbol for 10 is SN, and 4 means it's 4 plus. Hydroxide is up here. It's one of the polyatomics that doesn't end in 8 or ite. It ends in IDE. OH1 minus. Now we can swap and drop. A 1 goes down here. 4 comes out the parentheses. Outside the parentheses, we get SnOH4. Lithium carbonate. No prefixes, so I know it's ionic. Lithium is Li. Its charge is 1 plus. Carbonate, it's right there. ATE tells me it's a polyatomic ion. Parentheses CO3, 2 minus. Swap and drop, we get a 2 on lithium and a 1 outside the parentheses. Li2, CO3 in parentheses. That'll work. Okay, we've got 2 more to do in our 4.0 optional, our extension stuff. So we're going to do these 2 right now. Determine the mass of 3.48 times 10 to the 23 formula units of PbO2. So we're starting with formula units. In our mole map, that's in the top left corner. So we've got 2 conversions to do here, right? So we've got to go from formula units, which I'm going to abbreviate as FU. We've got to convert those to the middle of the mole map, which is moles, and then convert that to what they ask us. Mass is grams. So we're going to start with the number they give us, 3.48 times 10 to the 23 formula units. And we're going to convert that to moles. We're going to get rid of formula units and we're going to find moles. Our mole map tells us when we're dealing with the number of particles, formula units is the particle that is an ionic compound like this. 1 mole equals 6.02 times 10 to the 23 particle units. Or formula units are going to cancel out. But we're not done. We need 1 more conversion. So we set up another times in the line. We need to get rid of moles, put it on bottom. We need to find grams, put it on top. But we don't have that value. We've got to figure out the formula, the grams per mole for PbO2. So we're going to have to do a side problem here. Figure out the formula mass of lead 4 oxide. So Pb, right? We look up the formula mass on the periodic table. Is right there, 207.2. There's only one of those, so 207.2. And then oxygen is 16. We're going to multiply that by 2 to get 32. And then we're going to add everything together. Get, let's do 239.20 grams per mole. 1 goes with mole. That number, 239.20, goes with grams. And then moles can cancel. And now we can use our calculator, with parentheses here, to solve this in one fell swoop. So we're going to do 3.48 second E23 times parentheses 1 divided by 6.02 second E23, close parentheses, times 239.20 0.20, hit enter. We get 135.1 grams. And really, we're going to round that to 3 decimal places. So that's 135 grams of PbO2. Question number 3. Here we go. Similar. We're going to determine the number of molecules if we have a 100-gram sample of SO2. So this time we're starting with grams. 100.0 grams of SO2. And we're going to convert that until we find molecules. Well, we know that if we're starting at grams, to get to molecules first we have to go to moles, and then we can go to molecules. Spell it right. So, to get rid of grams, we have to find moles. Right? But we need some numbers here. We don't have the molar mass of SO2, so we got to figure it out. Just like up here, we had to do a side problem. Sulfur is 32.06 on the periodic table. Times 1 for the subscript leaves us 32.06. Oxygen is 16.00 times 2 equals 32.00. Add those together, and we get 64.06 grams per mole. And that is what we're going to plug in here now. 64.06 goes with grams. 1 goes with mole. That'll allow us to cancel out grams, but we haven't finished. We've still got to go to molecules. So we set up another conversion. To get rid of moles, we go on bottom. We want to find molecules. That goes on top. Our mole map tells us 1 mole equals 6.02 times 10 to the 23 molecules. Now moles will cancel, and we can put parentheses here and solve this problem. So we would type 100.0 times parentheses 1 divided by 64.06 times 6.02 second E23. Hit enter, and we get 9.397 times 10 to the 23 molecules of SO2. And I rounded that, so that's our final answer.